right. Translations. Remember, translations is when you move, slide a figure. All right. Which one is the first one? Which one is the second one?
The second one is the one with the
First one is just the regular letters. The second one is with the prime, little apostrophe over there. All right. So in this case, how did I slide this one?
To the right, left. I mean.
To the left for my X. Remember, I always do X first. So if I'm starting here, I've got to go until it matches over here. So that is 1, 2, 3, 4, 5, 6, 7 spaces to the left.
You got to count the little A too?
So I would say X minus 7. Everybody with me?
Yeah.
All right, so I did 7 spaces to the left. Well, then I've got to say, well, I'm going from here down to here.
0, 1.
1, 2, 3 down. So that's Y minus 3. Remember, left and right is for your X, up and down is for your Y. All right? So if it gives you, it says the function thing we're going to go by, this part right here, all you got to do is say -2 minus 8 for my X. -2 minus 8 for my X, and then 4 plus 2 for my Y. So that would be -10, 6 would be my answer. Alright? So if it gives you the rule, you just plug the numbers in. If it's something like this, you're still going to do the same thing. I'm going to take this X and plug it in there. So it would be 2 times 1 plus 2, and then take this Y, plug it in there, 2 minus 3, so 4, -1 would be my answer. If it gives you the image and says, go back to the pre-image. All right? You're going to undo whatever is up here. So I would take this and say 5 minus 12, and then -29 plus 17. Everybody got me? If you got the image and you got to find the pre-image, you undo whatever's in the rule. So that would be -7, -12. All right, reflections. You're just going to have to be able to remember these now. They don't give you anything on the formulas. All right? If we're reflecting across the x-axis, which one is my x and which one is my y? There's my x, there's my y. So if I'm flipping it over the x-axis, all I have to do is change the sign of the y. It's flipping over the x, change the sign of the y. So if I have this, how would this A part change? What would it be?
-4, -7.
4, -7.
Oh, you said
Change the y.
Oh,
Change the sign of the y. I will leave the x part alone. If it's reflect across the y-axis, all we're going to do is change the x. So this would be -4, 7. And again, we're flipping it this way, left and right, not up and down. Reflect across y equals x. Now remember, right, y equals x looks like this. Right there. So when I reflect it across that, what am I doing?
Change both signs.
I'm not changing signs.
Swap.
You swap.
I swap the order. I change the order. The x and y switch places. So what would happen on this B number right here?
-12, -7.
B prime would be -12, -7.
Do you want to change the on negative sign either?
No, you don't change the signs on reflecting across y equals x. You do change the sign on y equals -x, which looks like this. There's y equals -x. So when I flip it across y equals -x, I swap the order and change the signs. So what would this first one be?
-6, -4.
-6, -4. A prime. All Lines of symmetry, what do lines of symmetry do?
Have to, yeah.
Have to be the same.
It's like you can cut
It's
it in
got to
half.
cut it in half and be the same on both sides. So I could do this right here, fold them, they'll be the same.
Cross it.
I thought you would know when they're the same when they got a right angle.
It doesn't have to have a right angle.
Go down the middle.
If I do this right here,
It's not the same.
that is not.
Yeah.
You sure it's not?
It's like,
Yeah. Fold that down. So that one would have 3.
yeah, we got 4. I mean,
Does it?
There's one.
2.
across.
Got that one right there. No, right there.
That one's got about 3.
Got 5.
Does that work right there?
No.
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 Does that work right there?
No.
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 Does that work right there?
No.
Yes.
Oh, yeah, yeah. Nah, but him. I don't get how that
I
works.
told you got 5.
I didn't say you were wrong.
I was trying to.
All right, if we want to do these right here, let me go back. It says reflect across x equals 1. First thing you got to understand, what is x equals 1?
0 on 1.
X equals 1?
What kind of line is x equals 1?
1.
Go.
A line.
Vertical.
Vertical, horizontal, that's what I need.
My bad.
X equals 1 is right there. X equals vertical. Y equals horizontal. So, how can I reflect this across x equals 1?
Go over that thing one time.
See how far these points are from that line. So this point right here is 1 space away. So I go 1 space on the opposite side.
0, 2.
This is 2 spaces away. So I go 2 spaces over there. This one is 1, 2, 3, 4. 1, 2, 3, 4. You got your figure reflected. If it says y equals, what kind of line is that?
Horizontal.
That's horizontal. So I'm going to say y equals -2 is going to be down here. So what do I do now?
Do the same thing.
Same thing, count. 1, 2, 3 spaces above it. 1, 2, 3 spaces below. That's going to be the same thing there. 1, 2, 3, 4, 5. 3, 4, 5. There's your figure. All right. All right, for rotations, this is when we talk about doing 90 degrees, 180 degrees, clockwise, counterclockwise, all that stuff. All right. If it's 90 clockwise, first of all, which direction is clockwise? To the right. You're going to the right. 90 degrees, if here's my graph, and I start up here, where is it going to be? Well, first of all, what quadrant is that?
First.
That's quadrant 1. What is this?
2. 3.
3 and 4. So 1, 2, 3, 4. If I rotate that 90 degrees, where is it going to be?
The fourth
It's
quadrant.
going to be in quadrant 4. If I rotate it 90 counterclockwise,
The third.
it's
Second
going to be in
quadrant.
quadrant 2. All right. So knowing that should help you line these things up. The rule for 90 clockwise is you change the sign of the X and swap the order. Change the sign of the X and swap the order. Now, notice what it says here at the bottom. It's the same as 270 counterclockwise. For every 90 degrees, how many quadrants do you move?
1.
1 quadrant. So if I do this, it's going to wind up right here. Or I could flip here for 2, or for 90 counterclockwise, 180, and then 270 will be back in the same spot. So 90 one way is 270 the other way. Again, what does the rule say? Change the sign of the X and swap the order. So what would I do here?
3, -7. I mean +7.
3, +7. Change the sign of the X and then swap the order. All right. What would this next one be?
4
4
negative 1.
-1.
And then,
1 negative 3.
all right. And which 2 rules are that? What does that work for?
270 counterclockwise and 90 clockwise.
There we go. All right. 90 counterclockwise. So which direction am I going counterclockwise?
Left.
To the left. What do I do here?
Change the sign
Sign of the Y, switch the order.
Yeah.
So this would be negative, I was gonna say, are we changing the X? No, we're changing the Y.
Negative 2, so
180, what do we do?
Change both of the sides.
Only change the signs. Do you need to say 180 clockwise or counterclockwise?
No.
No, because it's gonna be in the same spot. So what would I do here?
82. 82.
All you're doing is change the signs. All right, so look at this real quick. We already talked about it, 90 degrees clockwise, one quadrant to the right, so 90 degrees counterclockwise would be one quadrant to the left. 180 is 2 to the right or 2 to the left, it really doesn't matter which way you say that. 270 clockwise is 3 to the right. Let's do one of these. It says 90 clockwise. What did the rule say for 90 clockwise?
Change sign of X.
Change the sign of the X, switch the order. So if I'm doing this one, and I want to change the sign of the X,
One and 4.
and then B prime would be
4 and positive 3. And 0 and positive 1.
now. If I'm doing 90 clockwise, which quadrant should that wind up in?
The first quadrant.
It should wind up over here. If it doesn't, we've done something wrong. So 1 4 here, 4 3, and 0 1. And wound up in that quadrant. What about 180? What did it say to do on 180?
change both the sides.
Change the signs. So that's going to be 4 negative 1. B prime is 3 negative 4. C prime is. Why is it still 0?
Because 0 and not the difference.
You can't change the sign to 0. There is no sign. Where should this one wind up?
On the
The fourth quadrant.
If I move it 2 quadrants, 1 2, or 1 2, it doesn't matter. It should wind up in quadrant 4 when I get done. 4 negative 1 is here. 3 negative 4 is here. And 1 0 is there. What about this one where it says 270 counterclockwise? What is that the same as?
90 clockwise.
That's 90 clockwise. What's the rule for 90 clockwise again?
Change sign of X and then flip
Switch the order. So A prime would be, B prime would be, B prime would be
Oh, negative 4, negative 5.
negative 5, negative 4, switch the order.
Oh, yeah, that's right. Negative 6, negative 2. Negative 1, negative 1.
Where should this wind up if I'm going 270 counterclockwise?
In the third quadrant.
If you go from here, there's 90, 180, 270. So it should wind up over there. Negative 2, negative 2. My A prime. B prime is negative 5, negative 4. C prime, negative 6. Over there somewhere. D is negative 4. All right. What are the possible answers for this as far as how I could rotate it?
90 counterclockwise. No. Yeah.
90 counterclockwise.
I'm waiting on y'all.
90.
Not 270.
90 counterclockwise
270.
or 270 clockwise. It's the same thing. What about this one?
180 either way.
180 either way. Now, what do we need to do here? If you don't see it, write down the points and then see which rule it matches up with. Does that make sense? So write down the points for each one and see what you did. So for A, well, let's do B, make it better. B is, not B prime. B is, what is that, 2, 3? What is B prime?
B prime is 4, 2.
What?
No, 4, negative 2.
What? 1, 2, 3.
Oh.
1, 2. All right, so what did I do? I switched the order and I changed which one?
X.
So what is that?
90 clockwise.
There you go, 90 clockwise. That's what it is. So if you can't see it because it's all jumbled up on top of each other, write down the points and then say, oh, well, what did I do? Switch the order, change X, that's 90 clockwise. All right, for dilation, what do we do?
It's the changing in the size.
It changes the size. The shape stays the same. So if it's a triangle, it's still going to be a triangle. If it's a square, it's still going to be a square. It's just bigger or smaller. Make sure you understand this down here at the bottom. If the scale factor is greater than 1, what happens?
It gets larger.
It's going to get bigger. If the scale factor is 1, stays the same, nothing changes. Because when you multiply by 1, nothing changes. If it's between 0 and 1, it gets smaller. Now, when it's between 0 and 1, what's it going to be?
Fraction.
It's going to be a fraction. Now, I say it's going to be a fraction. What if the fraction is 5 over 2?
Then you divide that out.
What is 5 over 2? Which one of these is 5 over 2?
1.
It's greater than 1. So even though it's a fraction, it will get bigger. So when I say fraction, I'm talking about a fraction smaller than 1. All right, how can I look at this right here and tell if it's dilated or not? Now, figure 1 is by itself, so that's the original. That's what we're starting with. All right. So how can I tell if figure 2 is a dilation of figure 1?
The Y.
Can I multiply these numbers by something and get the second set of numbers?
Yes.
What can I multiply by?
2.
So then the scale factor is 2, and you know it's a dilation. So if I go to figure 3 over here, is figure 3 a dilation of figure 1?
No.
It's not?
Well, it gets smaller.
Can I divide by something?
A half.
All right, now, what people normally see this and say, oh, I divided by 2. Scale factor does not work on division. So you've got to say, I multiplied by 1/2. So if you divide by 2, you're multiplying by 1/2. If you divide by 3, you're multiplying by 1/3. If you divide by 4, multiply by 1/4. It's the same every time. What about this last one over here, figure 4?
It's
Wait.
What happened to the x's?
stay the same.
They stayed the same, but what happened to the y's?
They change.
So did I multiply them by something, the same number for both parts? No. The x's I multiplied by 1. The y's I multiplied by 2. That one is not a dilation. So here we said, yes, scale factor is 2. Yes, scale factor is 1/2. And then no. So what's the scale factor on that one?
0.
Nope.
Nothing.
You don't have a scale factor because it didn't work. How would I check these right here?
The points.
Write the points down, see if you can multiply or divide, and figure out what the scale factor is. So if I did this figure 1 right here, that would be 0, 2. And make sure you go in the same order now.
2, -1.
All right, and then figure 2 would be, I got to do the same order. I went here, here, and there. So I got to go top, 0, 4, 1, 2, 3, 4, 1, 2, there. And then the last one over here would be -4, -2. All right, so is figure 2 a dilation of figure 1?
Yes.
What's the scale factor? Is figure 1 a dilation of figure 2?
Yes.
What's the scale factor then?
1/2.
It'll be 1/2. All right, we have to know this stuff on triangles. There's going to be a bunch of triangles if it's like it's been in the past. What does corresponding mean? It's in the same spot. All right. So angle A would match up with what on the other one?
E.
Angle F. A and F are the same because they both have the 1 mark. Angle B would match up with angle D. And angle C would match up with angle E. So that's how I would write. Angle E is equal to, or angle A is equal to angle F. Angle B is equal to angle D. Angle C equals angle E. The angles are the same. If it's similar figures, the angles are the same. Are the sides the same?
No.
No, because what does similar mean? Same shape, different size. So you don't put the sides being the same. I would just say that AB corresponds to what?
FD.
And how do I know it's FD? Follow the angles. A had a 1, B had a 2. F has a 1, D has a 2. Which one does BC correspond to?
D.
DE, follow the angles. And then that means AC would have to correspond to,
FE.
Fe.
notice they are not the same. I didn't put them equal. Corresponding doesn't mean the same as far as length goes, it means the same as far as angles goes. All right, extremely important right here. How do we solve these right?
But you
Over
say-
12.
If I do x over 12,
4 over 8.
is that the only way I can set it up?
No.
What else can I do?
You can do 12 over 8.
I can say 12 over x, but then I've got to say
8 over
8 over 4. Wherever you start the first time is where you start the second time. On this way, the first way, we went little triangle to big triangle. Second one, we went big triangle to little triangle. You're going to get the same answer no matter what. How do I solve those?
Cross multiply.
Cross multiply and then divide. All right, so tell me about this one right here, the second one.
X over.
If I do x over 5, then I've got to do
6
6
over.
over 4. All right. You need to understand that right there because there's going to be quite a few that you can get answers on that. All right. What about this right here? When they're not looking the same, what do I probably need to do?
Find the angle.
But what do I need to do before I start doing some numbers?
Oh, change the.
I'm going to change one of the triangles so that they look the same and they're oriented the same way. So I'm going to take this right here and go and put that angle in the corner. So now they look the same. Well, when I do that, what did I actually do to this triangle to get it over here?
You rotate it.
I rotated it. So that means everything's got to rotate and turn with it. So where does the 4 go? It's going to go over here. The 10, the 4 and the 10 are around the angle, so they still got to be around the angle. That leaves the 8 right there. Once you have that, then you should be able to set up the triangles or the proportions. Same deal, what am I going to do? I'm going to flip, reflect, rotate something to make them look the same. And we'll go from there. All right, how did we use the scale factor to figure out area? Anybody remember?
Multiply.
First thing I got to do is figure out what is the scale factor. 5. Where is that coming from?
6 multiplied by 5 is 30.
Yeah, I take the big one, or the second one, let me say that, the second one, and divide it by the first one. 30 divided by 6 gives me the 5. What do I do with the scale factor though?
You
Got to square it. Alright? Because what do you do on every area problem you ever do? You square something. It's something squared. Meters squared, feet squared, inches squared, whatever. So I square it and get 25.
What's 20?
20 is the area of this first one. I'm trying to find the area of the second one. Well, this right here, this 25, just told me the second one has 25 times more area than the first one. So I would say 20 times 25 and get my answer. What is that? 500, I think. Oof. What would I do on one like this? What's the scale factor right here?
4.
4.
No, 1/4.
It ain't 4. Remember, second one divided by the first one. So the scale factor is going to be 3 over 12, which is 1/4. What do I do with that scale factor?
Square.
Squared. 1/4 squared. And people always get messed up on fractions when you're squaring them. It's very simple. What is 1 times 1?
1.
What is 4 times 4?
8.
There's your number. Alright. What do I do with that 1/16 then?
Multiply.
Multiply it by that 64 over there, and that'll tell me what happened to the area. Alright, we'll get this and we'll stop. You've got to be able to do these word problems right here. A building 300 feet tall casts a shadow 47 feet long. What do I need to do? Draw the triangle. So a building 300 feet tall. Where does the tall part always go? That's up and down. That's the height. Cast a shadow 47 feet long. Where do shadows always go?
Bottom.
That's always on the bottom. How long would the shadow of a 22 foot tall tree be? So 20 feet tall, 22 feet tall for the tree is there. Where's the shadow? At the bottom. Set it up and solve it. Now they may even have questions like a person can do 20 problems in 15 minutes. How long would it take them to do 30 problems? You understand that's the same thing as this right here, right? If I had that, person can do 20 problems, let's say in 15 minutes. How long would it take for 60 problems? How would I set that up?
20 problems.
Make a fraction. 20 problems takes 15 minutes. So there's my problems, there's my minutes. All you got to do for the second part is do the same, put the same thing in the same spot. 60 problems goes where? On the top, because I put problems on the top on that one. How many or how long? X minutes would go there, and then you solve it from there. So all of these are the same thing, it's just used in different ways.